So when dealing with the rainwater, one of the things that I need you guys to kind of think about, right, is where's the water going? Okay? Because that's one of the things that's probably confusing for you guys is like, oh, what do there's too many factors, right? Deer in headlights, right? And it's easy to get that way. And so when you get that way, one of the things that you can do is revert to graphics. Because graphics sometimes are an easier way for you right-brained people to think about things and this right-brained person to think about stuff. That's when I started doing it this morning. It's like that's exactly what I did. As I went to graphics. So let's first of all let's think about this. We're trying to figure out how big is our basin and what's the water doing. So we've got rain that's going to be falling, right? So we have rain coming down. We've got a sloping site. And we got to figure out how big to build a detention basin. So water is going to do one of two things, right? It's either going to land on the ground and go downhill or into it. That's one, right? So that is what we will call the sponge effect, okay? So if I take a sponge, right, and I take a dropper. So say I have a big sponge and a dropper, and I take a dropper and I put drops on the sponge. What happens? It lands on the thing and it soaks it in, correct? Now imagine if I've got a big sponge and a pitcher of water, and I just pour the pitcher onto the sponge. Is it going to absorb all that water?
No.
Some of it will go into the sponge and some of it will run off, right? That's what the landscape and dirt areas of your site do. They absorb a portion and a portion runs off. So that's one of the things to think about. So we'll call that the sponge and pitcher. Of beer. No, pitcher, just pitcher. Wishful thinking, I'm sorry. Okay, so now there are other areas of the site, right, that no matter how much water you pour on them, it doesn't go into them, right? So that's the roof, any paved area, the pool, correct? So those are going to be impermeable. The first one is permeable. All right? So permeable and impermeable. Now there's something complicating the impermeable areas, isn't there? Let me ask the question. Is a roof impermeable? Is a swimming pool impermeable? Is concrete impermeable? Relatively. Yes. So water falls on those things. It's like this table. If I tilt this table up, right, and I pour water on it, it's just all going to run off, and it's going to end up on her lap. And she's going to go, see, that's why I dropped your class. You got water in here?
No way.
Yes. Okay, anyway, so, we got a water bottle. Man, you ready? All right, so we got permeable and impermeable. But there's something that's messing up, because these two calculations would be very easy, right? How much area is impermeable? How much area is permeable? But there's something that's mucking the waters here. What is it? Think about it.
Because it depends on how much water go to impermeable, that's go to a drainage.
Nope, that's not the problem here. The problem with the impermeable, there's an issue that screws things up.
It's overflow.
It's not a percolation rate, because impermeable surfaces do not have percolation rates. Let me ask the question a different way. Is all of the water that falls on the impermeable surface going to go into the dirt? No, tell me, why not?
Because some of the
Some of them's going to go where?
Drainage, the sewage.
The sea witch?
The drainage.
Sea witch?
I don't know.
Yeah, you mean the cistern?
No,
No,
the sewage.
No, we're not trying to put water into this. The stuff that falls on impermeable surfaces isn't going to the sewer.
It's gonna end up on the permeable?
No, we're talking about, right now we're talking about the permeable areas.
Oh, permeable.
Permeable, right? No, I'm sorry, we're talking about impermeable. You're saying it's going to end up on the permeable?
Like it's gonna overflow onto the impermeable areas?
That's a portion, but is there another problem going on with this problem? God, I've already hinted at it twice. I've even said the word.
The cistern.
A portion of what falls on the non-absorbent, impermeable surfaces is going to go into the cistern. Okay? So if we diagram that over here, we've got, I'm going to use black so it's more visible. So we've got some areas are permeable. We've got a building with a roof, right? And a cistern. So the rain that falls here goes into the ground. The rain that falls here goes into the ground. The rain that falls here goes into the ground. The rain that falls here does not. It goes into the cistern. The rain that falls here goes into the cistern. So we have to figure out how much of this area there is. So that's the first problem, right? A portion of the water that falls on the roof has to go to the cistern. So now the next problem occurs. We're assuming that the cistern is empty. We are also assuming that the maximum volume of the cistern is 4,000 gallons. I'm purposely throwing a bunch of different units to make you have to convert the units. You have to think about stuff. You know, when you take building structures, you don't want to end up like Uncle Iggy over here that always messed up in conversion of units and understood the structural calculation but got the number wrong. Okay? So a portion of what lands on the roof has to go in the cistern, but the cistern is 4,000 gallons. So the question is, how much water falls on the roof in 1 hour? Is it more than the cistern capacity or less? Now, again, that's the next question you got to ask yourself. If it is more, so let's say that 5,000 gallons falls on the roof and the cistern is only 4,000 gallons, that other 1,000 gallons is going to go onto the site. Okay? All of the water that falls on the concrete, right, is going to go onto the site. So if we look at this, we say, okay, so we're going to establish permeable areas. So I'm going to first establish impermeable areas. So I'm going to put a pool deck here, and a swimming pool, and a pool deck. So everything in red is impermeable. And then there's a house with a roof with a 3-foot overhang. So this is all impermeable, all the way to the edge of the overhang. Okay? So that whole area is impermeable. And then there's the driveway going down the hill. Okay? That's also impermeable. Any water that falls from here to here, and I'm gonna add some concrete in the front yard. Right? So there's concrete in the front yard right there. Any water that falls from here to here, right? That water is going to run onto the site. Okay? Any water that falls on the roof has to go to the cistern, but we have to basically say when if there's more water than will fit in the cistern, the overabundance will go out to the site. So one of the things you might have to calculate is cistern overflow. rainwater capture, cistern size, and cistern overflow. If it's less than 0, it's 0. Okay? All right. Does that make sense? Yes? Okay. So I showed you how one of the approaches that I took the site, right? And I showed it to you guys up on the screen earlier. So I took that site, and what I did is I put in a hatch on all of the impermeable areas, right? And when you look at it from above, you can see that. Like, for example, you might have walkways and a planter. So say you've got your house here with your roof overhangs, right? And let's say you've got a driveway coming up like this, right? And then you've got a walkway that goes around the house, but there's a planter, right? So what I did is I hatched, right, any area that when I look at it from the sky that will suck up water, I hatched it, and then I got an area calculation for that. So did something like this. So all of this is impermeable area, right? And this part in here is permeable. So what I would do if I were you guys is go back to your site plan for the design that you came up with. You need to make sure that it shows, hey Stephen, I'm in class, I'm going to have to call you back, but I really need to talk to you, okay? All right, bye. That's one of our advisors for the architecture program. So does this make sense? So what I would say right now to you is make sure your site plan shows your impermeable areas, your roof, your wall, and your permeable areas. And then hatch them 3 ways. Oh, sorry, 3 ways. I would like you to put a green hatch any portion that you see from the sky that absorbs water. I would like you to put a gray hatch on any part that does not absorb water except the roof. And I want you to put a blue hatch, a blue solid hatch on the roof. Got that? So then once you do that, and you color code it into those 3 colors, right, you have the most important areas in figuring this out. Okay? And most of you probably have already got that information ready to go. So, all right, we're going to stop